All right, let's go ahead and take a look at rate problems video 1 here. Number 2, let's go ahead and read it together. It says, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t, for 0 is less than t, which is less than 12, where f of t is measured in pounds per hour, that does sound like a rate, and t is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by g of t, for 3 is less than t, which is less than 12, where g of t is measured in pounds per hour, and t is the number of hours after the store opened. So I emphasize the word rate because I think that it gives us an idea of what level the functions that we're given in a very complex problem like this, what level our function is at. Okay, the first thing I notice is that we have two different functions, f and g. And before both of them, they had that word rate. And that clues me in that I'm at a first derivative level. Okay, that is a rate of change, okay, at any specific moment in time. So sometimes when we get to a fairly complex problem like one of these, I'm going to go ahead and draw myself a picture at the bottom just to give myself a visual. So I'm going to draw a very fancy grocery store banana table here. Let's go ahead and label it banana table. All right. And I'm going to go ahead and start to label some of the things. And the first thing I'm going to label is my function f. That was given to me first. Okay, it said customers remove bananas from that table at a rate modeled by that function. So that's going to be bananas leaving my table at f of t, and that's in pounds per hour. Now, second function that we were given was g, and g was the rate, right, that the employees brought the bananas back to the display table, or stocked them onto the display table. So over here, I'm going to have g of t, also in pounds per hour. Okay, so I have a very crude drawing of a banana table that shows me how my bananas are being brought to the table and how my bananas are leaving the table. Now, at this point, usually I'll go back through and I'll read the problem one more time. Okay, I'm going to go through and now try to comb through the rest of the information. Maybe I'm going to add some more things to my picture to give me more clarity on a problem that looks like this. So let's go back through it one more time. When a certain grocery store opens, it has 50 pounds of bananas on the display table. So I have 50 pounds that are already on my table when the store opens. So I'm going to go back to my drawing. 50 pounds at opening. When the store opens, that's sounds like at t equals 0. So I'm going to add that to my picture. Customers remove bananas from the display table at a rate modeled by this, for 0 to 12. So maybe I'll go down to my picture and I'll say from 0 to 12. All right, where f of t is measured in pounds per hour, we've got that. T is the number of hours after the store is opened. Okay, after the store has been open for 3 hours, store employees add bananas to the table modeled by G. And again, they show its time going from 3 to 12 because they don't start restocking until 3 hours into the workday. So from 3 to 12. Where G of t is measured in pounds per hour, we've got that. And t is the number of hours after the store opens. So now we've got a pretty good picture. We've got a rate in, we've got a rate out, and we've got 50 pounds of bananas on the table when the store opens at t equals 0. Now I think we're ready to try and attack letter A. Let's go ahead and read letter A. It says, how many pounds of bananas are removed from the display table during the first 2 hours the store is opened? So as I read that, the first thing that jumps out to me is just the word removed. Okay, I don't care how many bananas are on the table when we start. I don't care about stock boy or girl or whoever putting bananas back onto the table. I'm only interested in things leaving the table. And if I'm only interested in things leaving the table, that means I am interested in F of t in pounds per hour. So I'm looking at, or I have information about F of t in pounds per hour, and I'm asked about pounds of bananas. I want to go from a rate, a first derivative level, to a pounds, an original function level, right? It's not a rate of change at all. So how do I get from a rate to an original function? Well, I'm going to do an integral. Now, because we're only removing bananas, I'm going to integrate f of t dt. And if you wanted to, you could put that 10 plus 0.8 sine of t cubed over 100. You could actually write that out there if you wanted to. I'm just going to write it as f of t. It's the same sort of thing. And I want the number of pounds of bananas removed from the display table during the first 2 hours. So that means I want to go from 0 hours to 2 hours. So this is a calculator question. So go ahead and plug that into your calculator. I have already done that. I'm going to call it 20.051. And now I'm going to write a sentence or a statement just to kind of sum this up. So during the first 2 hours, right? We're going to give our time independent variable, right? First 2 hours, 20.0511 pounds of bananas. Oops. Spelling is a thing. Are removed. All right, let's jump down to B. B, find f prime of 7. So I'm just going to stop there. We'll go back to the other part of this letter B here in just a second. F is removing. So we're still talking about removing. And we want to remove or find f prime at 7. So that's just a calculator question, right? We can do f prime of 7 here by just taking the derivative of this in our calculator and evaluating it at 7. So again, I've already done this. Negative 8.120. Oops. So we have f prime of 7 being evaluated and getting negative 8.120. Now I think we're ready for the second part. Let's go ahead and read that. It says, using correct units, explain the meaning of f prime of 7 in the context of the problem. So let's go back up and f of t, take a look at what f of t is in terms of. F of t is in terms of pounds per hour. So that is pounds per hour. So I want to know what are my units for f prime of t, which means that I want to take pounds per hour and essentially take the derivative of it. So think of other rates that we know. Meters per second, feet per second. If we took the derivative of those first derivative levels, we would end up getting meters per second squared, or meters per second, or feet per second squared, feet per second. It's the same thing here, right? We have pounds per hour now per hour. So f prime of t is going to be pounds per hour. And you could say per hour or per hour squared. So let's go ahead and try and write a sentence now. Now, we want to center this at a time. So we're going to say, so after store is open for, 7? Yeah, 7 hours. The bananas, can't spell bananas today. The rate, the bananas rate, right, is negative, so we're decreasing. at 8.120 pounds per hour squared. Now, notice if I say decreasing, because we have a negative pounds per hour squared, if I say decreasing, I'm just going to decrease at the positive number here. If I decrease at a negative rate, the double negative there would change that to be positive. So if you're going to say decreasing, make sure that you make that 8.120 positive. All right, let's go ahead and flip over to C really quick. C says, is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? So if I want to see if something, or if my pounds of bananas are increasing or decreasing, that means I want to take a look at my derivative level. I want to be able to compare the rates to be able to tell if I'm increasing or decreasing. So I'm going to bring my picture back here really quick. My rate of bananas being placed onto the table is G of t. That's a positive rate. That would increase the number of bananas that come to my table. So if I want to take a look at bananas coming on, I'm going to take a look at G of t. Bananas coming off my table come at a rate of f of t. Now, if they're being removed, the number of bananas are decreasing. So that would be a negative rate. So I can say G of t, bananas coming in, minus f of t, my rate going out, will let me know whether or not my bananas are increasing or decreasing. So if I want to take a look at this, I want to have this happen at t equals 5. So I want to be able to see how many bananas are coming at G of 5, coming onto my table at G of 5, and I want to see how many of my bananas are leaving at f of 5. Now, again, we've got two very complex functions here. Just go ahead and plug 5 into G in your calculator and subtract 5 in f, and I think we'll end up with a value of negative 2.2631. Now, this tells us that f of 5 is bigger than G of 5 because we ended up with a negative answer. So, because G of 5 minus f of 5 is less than 0, right? It's negative. Then we can say the number of pounds of, got bananas right that time, at t equals 5 is decreasing. Okay, and this right here is our reason for our answer, right? We're comparing G of 5 minus f of 5, and then we're drawing our conclusion that the amount of bananas is decreasing. Okay, let's jump down to D. One more little problem here. How many pounds of bananas are on the display table at t equals 8? Okay, again, I'm going to bring back in our picture from the other side. Okay, and we've got G of t bananas coming onto the table. We've got 50 pounds of bananas starting on the table, and we have f of t bananas coming off. So I'm trying, and these are rates, right? Our equations here are rates of change. For letter D, I want to know about pounds of bananas. So I want to go from rates in F and G back to pounds. Those sound like integrals. So I'm going to integrate these functions. So G of t, if I integrate G of t, that's going to tell me how many pounds of bananas over the first 8-hour span, how many pounds of bananas are put onto the table. Now, remember, they don't start restocking bananas on the table until 3 hours into the day. So our integral is going to go from 3 to 12. And these are accumulating bananas. Now, we also have customers coming in, right? They are taking our bananas off the display table over the time from 0 to, I guess we're only going to 8 here. So we're not going all the way to 12. I'm sorry. I'm going to call that 8, from 3 to 8. Now, we also have to take into account, let's go back to F. We have to take into account taking bananas off. That happens starting when the store opens at 0. And it will continue to happen all the way till t equals 8. That's going to be of f of t dt. But remember, these are bananas that are being removed. So we are going to subtract that accumulation of bananas. And last thing we have to take into account, we also have to take into account that at t equals 0, we start at 50 pounds of bananas. So we're going to say, way out front here, we're going to start with 50 pounds of bananas, accumulate, because our stock person is putting bananas on from 3 to 8, and then we have customers removing, starting when the store opens at 0 to 8 as well. So this is, again, a calculator question, and I've already done that. I ended up with 23.3473. And these are pounds of bananas. Pounds of bananas. And this is at t equals 8 hours. All right, that's good for today. We'll jump into another one of these rate problems tomorrow. If you have any questions, please feel free to shoot me a quick email, and I can clarify anything here for you.